All right, these are Unit 11 notes for chemistry, and this is the unit on water, aqueous systems, and other solutions. Part 1 is about water and its properties. So water is found on the Earth's surface. It's in deep underground reservoirs, and it's in ice and snow. Our understanding of chemical reactions that occur in aqueous solutions depends on what we understand about water. So really 97% of the water on Earth is salt water. Only 3% of it's fresh water. And then in that 3%, it's actually, most of it, 68.7% of it's locked in ice caps and glaciers. There's only 30.1% of it that's groundwater. And then there's only 0.3% that's surface water. And then other 0.9% is just in other locations. But of that, surface water, that's what we think of most of the time when we think about our lakes, and 87% of the surface water is lakes. 11% of it's swamps and 2% of it's rivers. But when you really think about it, this little sliver right here breaks into this single one. This little sliver of this pie chart breaks into this. So, you know, it's really a small amount of water that we use. Now, water is unique in the fact that it is a bent molecule, okay? That is its shape because of its angles and how the oxygen and hydrogen react. The most electronegative atom in water is the oxygen. It pulls the electrons closest to it. So it's bent because it has a lone pair of electrons that push the bonded hydrogen atoms downwards, and that creates that paired shape, or that bent shape. And why is it polar? Well, that's because oxygen's strong electronegativity means that the shared electrons between the hydrogen and oxygen actually hang out around the oxygen more often, giving it more of like a negative dipole, whereas the hydrogen, since the electrons hang out more around the oxygen, they become slightly positive. So if we draw a line right here and split this atom, or split this molecule, we should be able to look at it so that the right side of it is all positive and the left side is negative. So that's what makes it polar, is when it has oppositely charged sides. So water is unique in its ability not only to form hydrogen bonds, but to form multiple hydrogen bonds per molecule. So this leads to many distinctive properties of water because it can do that hydrogen bonding, because those slightly positive hydrogens are attracted to the slightly negative oxygens of the other molecules. So the first thing that it creates is surface tension and cohesion. Now, water molecules within a liquid will tend to hydrogen bond in several directions with the other water molecules around it. This creates it to be cohesive, so it's attracted to each other. That's cohesion. Now, on the surface of the water, though, the surface of the liquid, the hydrogen bonds that form pull the water itself closer to each other, and so they're more attracted to the water than to the air. So that interface creates what we call surface tension. All right. So surface tension allows the water or the liquid to bead up. So all this water is like attracted to the other water molecules inside of it, not to the air. So it causes it to bead up, and that creates this surface tension between the interface of the air and the water itself. Now, surfactants are substances that interfere with hydrogen bonding, and so they reduce surface tension. Soap would be a surfactant. It actually creates it to where there's not as much surface tension. Now, low vapor pressure also is a unique property of water, and water has an unusually low vapor pressure. And what that means is that vapor pressure is the pressure exerted by the vapor molecules. So when it's in a gas form on the walls of a closed container. And so since hydrogen bonds hold water really close together, not many of its molecules form vapor molecules. And so thus its very little pressure is exerted when they're in their gaseous form. Okay, so that's why, you know, when water boils, it doesn't create a ton of pressure on the actual top, if you have the top on a covered boiling pot of water, it doesn't create so much pressure that it causes that metal to expand out and explode, because they just don't have as much pressure when they become vapor. Now also it has a high boiling point, and boiling involves adding enough energy to make it change from a liquid to a gas. Okay, and so water's strong hydrogen bonds means it takes a lot of energy for them to come in there and break those hydrogen bonds so those individual molecules can become in the gaseous state. Now also it has a higher density when it's in its liquid form, which is very odd. Most liquids tend to become more dense when they're frozen, okay, because their particles slow down and so they move closer together. Water, on the other hand, though, forms more hydrogen bonds as it's cooled, which actually forces the molecules a little bit more apart, which causes them to actually have a higher density when they're in liquid form than when they're in solid form. And that's why there seem to actually create these air pockets when it's in ice. So there's these little air pockets right here because of the hydrogen bonding that it locks into place. And so that's why ice floats, because the solid form is less dense than the liquid form. So I have some funnies, but we'll move past that. So I was asking that I gave you some YouTube videos here that you could copy and paste and click to and watch. Also, I was like, draw some water molecules. If they're in water form, these are the hydrogen bonds and it's really kind of close together. Whereas if it's in ice format, it actually breaks into these larger areas or spreads out and locks into place so that it has, so that the ice form is less dense than the water form. All right, so then I have some questions that you could ponder and try to answer. So these were the questions, and if you take a minute and write them down, you can then click through here, so you could pause the video, try to answer them, go back through the notes and see if you can answer them. Some of them you might not be able to, and that's why we were just kind of doing it in groups and kind of looking at it. So why can some bugs walk across the surface of a pond? And that's because of the high surface tension of water. And so why would the addition of a surfactant cause it to sink? That's because surfactants lower the surface tension by interfering with hydrogen bonding. Then how does hydrogen bonding affect water's vapor pressure? It makes it to where it's low, because the hydrogen bonds prevent the water from wanting to vaporize or become in gaseous form. What does water have, or does water have a high or a low heat capacity? It actually has a very high heat capacity because it has a very high boiling point, and so it takes a lot of energy. It'll hold a lot of energy before it'll change states of matter. What's the specific heat of water? You don't actually need to know this number because we're not doing calculations with it yet for thermo, but it is 4.18 joules over grams degrees Celsius. What effect does this have on the weather? It actually makes it very moderate because it takes so much energy to change the temperature of like the ocean and or the breeze at the ocean, because of the fact that there's a lot of water vapor in the air at the, so it's really humid at the coastline. So it takes a lot of energy to change the temperature. So it makes the weather moderate because of that. Explain in detail on a subatomic level why ice floats. Well, roughly the thing to remember is when water freezes, additional hydrogen bonds are formed. Those hydrogen bonds push the molecules further apart and lock it into a hexagonal arrangement, so it becomes less dense, so it floats. All right. Then what's the heat of fusion? Again, you don't really need to know this one. It's 6.01. And so that's joules per gram degree Celsius. Why is this less than the heat of vaporization? Because not all hydrogen bonds have to be broken for it just to change from ice to a liquid, but from liquid to a gas, all the hydrogen bonds have to be broken. Why is a burn from steam at 100 degrees Celsius worse than a burn from the same mass of boiling water? And that's because when steam hits skin, it will condense and it'll transfer its heat from the gas to your skin. And so all that heat, as it becomes a liquid again, will be absorbed by your skin. And so that will make it burn worse. Okay, so this concludes part 1, and the next video will be part 2.